Good afternoon, dear students of EX branch. I am Devendra Tiwari, Assistant Professor in EX Department, presenting here YouTube video lecture on the topic dot convention and mutual inductance. First of all, we will understand the concept of dot convention and mutual inductance, especially in network analysis. So let's start this topic. So as we know, when we want to decrease the complexity of any equation or any circuit from certain rules and sets of system. So here, dot convention and mutual inductance is one of them, which will be able to decrease this complexity. So we will see what is this mutual inductance. When the EMF is induced by self and mutual inductance, it occurs simultaneously. So the relative polarities of these two induced EMF must be determined before making any circuit calculations. So this induced EMF in a coil due to mutual inductance may be either positive or negative. That means it is adding or opposing due to self-inductance depending upon the sense of the windings and the direction of current in the coil. We will understand this concept in the next slide. How we will assign the polarities. So as we already know, this self and mutual inductance occur simultaneously. So polarities we are interested to find out. So dot notation or dot rule, we have to examine this. So the dot rule or dot convention may be stated as follows. If both current enters the dotted ends of the coupled coil, or we can say if both currents enter the undotted ends, then the sign of mutual inductance M will be same as the sign of self-inductance N. One more point. If one current enters a dotted end and the other ends enters at the undotted end, then the sign of mutual inductance will be opposite to that of self-inductance. It means if the current enters from the same directions in the coil, it will be given positive, and if the current entering from one section and it is leaving from other section, then it will be treated as negative. Now we go to the next slide. With the help of example, we can see the explanation. If these two currents, look at this circuit. If the two currents flow into each dot, their dots are mentioned already here. If the current flows into each dot or out of each dot, the mutual inductance M will be positive. On the other hand, if one current flow into a dotted sections and other leaves the dotted end, then the mutual inductance M will be negative. Here in this section, we can say inductance M is positive. Why? Because both the currents I1 and I2 flows into the dots, entering from the same side. That's why M is positive. To next explanation. Again here M is positive because both the currents I1 and I2 flows out of the dot. We can clearly see here I1 is leaving this dot and I2 is leaving this dot. That's why again this M is positive. In the previous case, I1 is coming and I2 is also coming. That's why M is positive. Now moving to next slide. This is the case where M is negative. So we can understand here in this first picture, we can clearly see that since the current I1 flows into the dot, whereas the current I2 flows out of the dot here. That's why this M is negative. Again, here we can see here this I1 is flows into the dot and I2 is leaving the dot. That's why this M is negative. Next slide. Consider this coupled circuit consisting of two inductors L1 and L2. Let V1 and V2 are the applied voltage. Each of these two currents, I1 and I2, are assumed to enter the dotted directions. Therefore, the sign of mutual inductance M will be positive, as we understand in previous slide. So I1, and clearly see here I1 is coming from dotted side and I2 is also coming from the dotted side. That's why this M is positive. By applying KVL, we can find out the voltage equations. This is V1 equals to L di by 1 dt plus this M di2 over dt. V2, and V2 will be given as L2 Ti2 over dt plus M Ti1 over dt. So in this way, we can apply the dot convention and find out the polarities of current by considering current is either leaving or entering the dot system. So this is the all about regarding dot convention. Hope you will understand this topic. Thank you for listening. Thank you very much.